Have you ever wondered what the Earth was like before humans existed? Millions of years ago, our planet was home to giant creatures like dinosaurs, mammoths, and ancient marine reptiles. They may be extinct, but their stories live on through fossils, rocks, and the history of life itself. But why should we learn about them? Because studying prehistoric animals helps us understand how life evolved, how Earth has changed, and what we can learn from past extinctions to protect the world today. Let's dive into the ancient past and discover the valuable lessons it holds for our future. Hard to believe, but the birds flying in our skies today share a surprising connection with one of the most fearsome predators in history, Tyrannosaurus rex. But how did this mighty dinosaur come to be? Was T-Rex always this huge and terrifying? In this video, we'll travel back millions of years to trace the incredible evolution of T-Rex, from small, feathered ancestors to the ultimate king of the dinosaurs. Ready to explore the ancient world? Let's begin. Number 1. Dilophosaurus was a small member of the Tyrannosauroid family. Yes, the same group that includes the massive Tyrannosaurus rex in it lived around 126 million years ago, during the early Cretaceous period, in what is now northeastern China. The name Dilong means emperor dragon in Mandarin, while Paradoxus refers to its surprising, even confusing nature. Because unlike most known tyrannosaurs, Dilong was small and covered in feathers. Dilong's fossils were discovered in the Yixian Formation in Liaoning Province, China, a fossil-rich area famous for preserving feathered dinosaurs. In 2004, paleontologist Xu Xing and his team officially described Dilong in the prestigious journal Nature. What made this fossil truly groundbreaking was the discovery of feather-like structures, or protofeathers, on parts of its body, especially the tail and trunk. This discovery challenged the long-held idea that all tyrannosaurs were scaly and hairless. Dilong showed that early tyrannosaurs likely had feathers, making it a key piece in understanding dinosaur evolution. So, what did Dilong look like? It was much smaller than T-Rex, measuring only about 1.6 meters, 5 feet long, and weighing an estimated 10 kilograms, 22 pounds, about the size of a large dog. Dilong had a long, narrow skull with sharp teeth, suggesting it was a carnivore that likely preyed on small mammals, reptiles, or early birds. Interestingly, Dilong's body combined both primitive and advanced features. For example, it had relatively long arms, unlike T-Rex's famously tiny ones, and its skeleton hinted at quick, agile movement. Its feathers weren't for flying, but served other purposes, and we'll talk about that shortly. Dilong Paradoxus plays a crucial role in understanding the evolution of tyrannosaurs. As paleontologist Gregory S. Paul explains in the Princeton Field Guide to Dinosaurs, Dilong shows us that T-Rex and its massive relatives evolved from small, feathered ancestors. This challenges the common stereotype of tyrannosaurs as giant, scaly monsters from the start. In fact, they started out small, fast, and, yes, fluffy. Over time, as some species evolved to become larger, like Yutyrannus and later Tyrannosaurus rex, they may have lost some or most of their feathers, as their size offered other forms of protection. So Dilong represents a transitional stage, a fascinating evolutionary bridge between small raptor-like predators and the giants of the Cretaceous. If Dilong couldn't fly, why did it have feathers? The most likely answer is insulation. Like modern birds, DeLong's protofeathers probably helped it regulate body temperature, especially in cooler climates. Some scientists also believe the feathers may have played a role in visual signaling, perhaps for mating displays or social behavior, much like how birds use colorful plumage today. And most importantly, the presence of feathers on DeLong supports the now widely accepted idea that modern birds evolved from small theropod dinosaurs, meaning birds are actually living dinosaurs. So, what can we learn from this little feathered predator? DeLong paradoxus wasn't just a cute cousin of T-Rex. It was a vital clue in the puzzle NOF, how dinosaurs evolved. Number 2. Guanlong Wukai. Guanlong Wukai lived around 160 million years ago during the late Jurassic period. The name Guanlong means crowned dragon in Mandarin, while Wukai refers to the colorful rock formations of the Wukaiwan Formation in Xinjiang, China, where its fossils were discovered. According to paleontologist Xu Xing and colleagues, who published their findings in Nature in 2006, Guanlong is considered one of the earliest known tyrannosauroids. It was relatively small, measuring about 3 meters long or roughly 10 feet, and was about chest high to an adult human. One of Guanlong's most striking features is a thin, high crest running along the top of its head. Scientists believe this structure wasn't for combat, but rather served as a display feature, possibly to attract mates or identify members of the same species. Guanlong was a small carnivore, likely hunting lizards, primitive mammals, or insects. Its sharp, curved teeth were well suited for slicing flesh, and its light build suggests it was fast and agile. What makes Guanlong even more fascinating is the evidence of primitive feathers found with its fossil. These weren't for flight, but may have helped with thermoregulation or served as visual displays, much like modern birds. Guanlong provides crucial insight into how small, feathered theropods gradually evolved into large apex predators like T-Rex. Despite the vast difference in size, Guanlong and T-Rex share key skeletal traits such as a strong jaw, long hind limbs, and similar skull structures. In Steve Broussat's book, The Rise and Fall of the Dinosaurs, he explains that Tyrannosaurs started small and only became giants tens of millions of years later. Guanlong is one of the earliest examples that help scientists trace this evolutionary path. This discovery also supports the theory that tyrannosaurs originated in Asia and later migrated to North America via land bridges. The first Guanlong fossils were discovered in 2002 by a team from the Institute of Vertebrate Paleontology and Paleoanthropology, IVPP, and the American Museum of Natural History. Since then, it has been the focus of continued study. Using advanced tools like CT scanning and 3D digital modeling, researchers are able to explore the brain structure, nasal passages, and balance system of this small predator in more detail than ever before. Guanlong Wukai is more than just another dinosaur. It is a powerful example of transitional evolution. It teaches us how evolution happens gradually, and how even small species can leave a big legacy. For educators and students, Guanlong is a perfect example to explain phylogeny, natural selection, and fossil evidence in classrooms. It shows how every species, no matter how small, is part of a much bigger picture. Number 3. Yutyrannus huali. Yutyrannus huali was first discovered in 2012 in the Yixian Formation of Liaoning Province, northeastern China. The name Yutyrannus translates to feathered tyrant, while Huali means beautiful in Mandarin, a tribute to the remarkable feather impressions preserved with the fossils. According to the study published by Xu Xing and colleagues in Nature, 2012, this dinosaur lived about 125 million years ago, during the early Cretaceous period, tens of millions of years before the rise of Tyrannosaurus rex. This finding provided the first strong evidence that large tyrannosaurs may have had feathers. Yutyrannus was an impressive predator, measuring up to 9 meters, 30 feet long, and weighing around 1.5 tons. While smaller than its famous descendant T-Rex, Yutyrannus remains the largest feathered dinosaur ever discovered. According to Thomas R. Holtz, Jr., 2007, it had a large skull with sharp, blade-like teeth, strong legs for running, and 3-fingered arms equipped with long claws. But its most striking feature was the thick, shaggy coat of feathers covering its body. These feathers likely served as thermal insulation, helping Yutyrannus survive in the cooler climate of early Cretaceous northeastern Asia. Interestingly, 3 Yutyrannus specimens were found together, leading paleontologists to believe they may have lived or hunted in groups. This social behavior is rare but not unheard of among theropods. With strong jaws, sharp teeth, and keen senses, Yutyrannus was well adapted to hunt medium-sized herbivorous dinosaurs such as Psittacosaurus, as well as other smaller prey. In his book, The Rise and Fall of the Dinosaurs, Stephen Broussat notes that early tyrannosaurs, including Yutyrannus, possessed highly developed olfactory senses, allowing them to track prey over long distances. The discovery of Yutyrannus revolutionized our understanding of tyrannosaur evolution. For decades, many scientists believed that large tyrannosaurs like T-Rex were entirely scaly. However, Yutyrannus proves that their ancestors likely had feathers, and that some later tyrannosaurs may have lost them as they evolved larger body sizes or adapted to warmer climates. Experts view Yutyrannus as a crucial evolutionary link, bridging the gap between smaller, bird-like tyrannosaurs and the gigantic, scaly apex predators that would dominate the late Cretaceous. Yutyrannus huali shows us that dinosaurs were far more diverse and complex than we once imagined. With its massive size, thick coat of feathers, and possible pack-hunting behavior, this dinosaur paints a vivid picture of evolution's many twists and turns. Finally, we come to the final discussion, namely T-Rex. Tyrannosaurus rex, or T-Rex, is one of the most famous and feared dinosaurs of all time. Its name translates to Tyrant Lizard King, perfectly capturing its reputation as the apex predator of its era. According to Paul G. Bond's The Illustrated Encyclopedia of Dinosaurs, 2003, a fully grown T-Rex could reach up to 12 meters in length, 4 meters tall at the hips, and weigh over 9 tons, about the same as a modern city bus. One of T-Rex's most striking features was its massive skull, equipped with powerful jaws lined with serrated teeth, each as long as a banana, up to 30 centimeters. Research published in Science, 2005, estimates its bite force at nearly 6 tons, strong enough to crush the bones of its prey with ease. But what about its tiny arms? Despite their size, paleontologist Jack Horner suggests these arms were incredibly strong and may have helped the dinosaur hold on to prey or push itself up from a resting position. Their muscles were far more powerful than they looked. T-Rex thrived in lush, semi-tropical environments filled with rivers, swamps, and open plains across what is now Montana, Wyoming, and the Dakotas. As a carnivore, it hunted large plant-eating dinosaurs such as Triceratops and Edmontosaurus. However, not all scientists agree that T-Rex was purely a hunter. According to Dr. Thomas Holtz of the University of Maryland, its keen sense of smell, indicated by large olfactory bulbs, suggests it may have also been an opportunistic scavenger, able to detect carcasses from miles away. For many years, T-Rex was depicted as a slow, clumsy brute, but new research paints a different picture. A study published in the Journal of Vertebrate Paleontology shows that its brain was large for its body size, particularly in areas controlling vision and smell. This suggests it was a clever, highly perceptive predator. Some fossil evidence even hints that T-Rex may have hunted in groups or displayed some form of social behavior. While this theory is still debated, it gives us a glimpse into a more complex dinosaur than we once imagined. Around 66 million years ago, a massive asteroid struck Earth, causing the mass extinction that wiped out all non-avian dinosaurs, including T-Rex. The impact left the famous Chicxulub crater in what is now Mexico, altering life on Earth forever. But T-Rex's legacy lives on. Believe it or not, modern birds are direct descendants of theropod dinosaurs, like T-Rex. So, in a way, dinosaurs never truly disappeared. They're flying among us today. Tyrannosaurus rex was more than just a movie monster. It was a real creature, a symbol of nature's power, evolution's creativity, and the mysteries of prehistoric life. Through its fossils, we continue to uncover secrets of the ancient world and gain a deeper understanding of our planet's history. Thank you for watching. Don't forget to like, subscribe, and hit the notification bell for more fascinating prehistoric discoveries. See you in the next episode.